What a beautiful view. If you want to see more scenery like this, please visit my channel above. At times it feels like one is floating in the clouds. Yeah. Speaking about floating, today I'm going to speak about the floating point numbers in Java. Welcome to lesson 17 on data types. There are two primitive data types in Java that represent the floating point. In other words, we use floating point data types to represent real numbers. But let's look at what is a real number. A number that contains a fraction part is known as a real number. Example of this is 25.25, 0.89, minus 2.33. Now we know that a computer stores all numbers, real or integral, into its binary format. Now there are two basic ways of doing this, namely fixed or floating point data types. Now the fixed point data type stores only the binary representation of the number and assumes that there are always a fixed number of digits before and after the point. Assume the number is using a 32-bit format which reserves 1 bit for the sign, 15 bits for the integral part and 16 bits for the fractional part. Now, negative 43.625 is represented as following. You can see there a 1 bit for the sign, then your 15 bits for your integer part and your 16 bits for the fractional part. Now the advantage of using a fixed point representation is performance, and the disadvantage is relatively limited range of values that they can represent. Now the floating point data type. This representation does not reserve a significant number of bits for the integer part or the fractional part. Instead, it reserves a certain number of bits for the number, which is known as the mantis or the significant, and a certain number of bits to say where the number, where on the number the decimal place sits, called the exponent. So here we got an example of minus 53.5, which is normalized, and as you can see, you got 1 bit for the sign, then you got the exponent part and the mantis part. Floating point representations are slower and less accurate compared to fixed point representations. However, floating point representations can handle a larger range of numbers with the same computer memory as compared to that of a fixed point representation. Now, Java supports a floating point number format. What is important about floating point numbers is that not all real numbers have exact binary representations, and therefore they are represented as floating point approximations. So let's look at an example of working with floating point numbers. Yeah, I've got a little application and in Java, and what I'm doing is I'm assigning this value over here to an int, and we did int before, so it's a whole number, an integral number in other words. And then what I'm doing is I'm creating a variable num2 of type float, and I'm assigning the int value to it. And then I'm taking this float again over here and I'm casting it back to an int value. Now what will the result be? Say if we now take n1, which that value which we cast to a we assign to a float and float back to an int, and we minus n3 from n1. We'd expect it to be 0, but let's just have a look. So what I'm going to do is I'm actually going to run this. I've compiled it before, so I'm just going to run it quickly. So I'm going to, let's compile it again, java main.java. Everything's running, it's fine. If I go here, ls, you'll see there's my main class. So I'm going to say java main, and this is the actual output I'm getting. So let's have a look here. There, if you look here, the first line I'm saying I'm printing out num1, which is that number, and look at num3, it's changed, and I'm getting a value of -25. Okay, I'm getting a value of a -25, and if you look at num1, its value is that, and then when I assigned num1 to float, it gives its floating point representation of that int. And then when I cast it back to an int, the number has changed. It was 239, now it's 264, because it's an approximation. Okay, so what I'm saying here is you'd expect that the value stored in int and num3 should be the same. However, they're not the same, because the value stored in the int num2, int num1 cannot be stored exactly into a floating point format in the float variable num2. Not all floating point numbers have an exact representation in binary format. That is the reason why num1 and num2 are not equal, num3 are not equal. Now we've come to the end of this lesson. We saw that Java represents real numbers as a floating point number. I hope you enjoyed this lesson, learned something from it, and please don't forget to press the subscribe button and the notify button. I've also got a Facebook page related to this channel. You are welcome to join my adventure channel, where I share photos and videos of various activities. Until we meet again in our next lesson, I wish you well and happy coding.